Hello student, my name is Imanshu and I am your science teacher. This video is for class 9th student of chapter number 1, Matter in our surrounding. So let's start. First term is matter. Matter is anything that occupies space and has mass. Matter is used to cover all the substance and the material from which the universe is made. It means you are surrounded by the matter because matter is everything present around you. Now we will study properties of matter. All matter consists of small particles. It means matter is made up of very small particles. We consider the particle as a small spherical structure. Second point, particle of matter have space between them. Particle of matter have space between them. Space can be very low or space can be very high. Particle of matter attract each other. It means two particles always attract each other. They exert a force on each other by which they attract each other. Next point, particle of matter are continuously moving. Particle of matter show three type of motion. It means particle of matter always moving and they can show three type of motion. First motion is translatory motion. It means motion in straight line. Translatory motion, it means motion in straight line. Particle can move in straight line. Second type of motion is motion around their own axis. It means particle can rotate around their own axis. This type of motion is called rotational motion, and the third type of motion is vibratory motion. To and fro motion about their mean position, it means vibration. In this motion, particles can vibrate around their mean position like this. They can not go anywhere, but they can just vibrate like into the solids. So into the next, we will study states of matter. There are three main states of matter. First is solid, liquid and gas. Find out the example of these three states. Now see, into the solid, particles are very closely packed. Into the liquids, they are far apart, and into the gas, they are very loosely packed. So this is the main point. What is the nature of particle into the solid? Into the solids, particles are very closely packed. Into the liquids, they are far apart. Into the gas, they are very loosely packed. Now three states of matter are clear. Two other states of matter also exist. First is plasma. Plasma is super energetic and highly excited state. You can see the particles are tend to move from the mean position. Into the Bose-Einstein condensate, particles are too closely packed. It is super chilled state. In this state, particles are very closely packed and force of attraction is maximum. Now on the next page, now we will study solid, liquid and gas. But before these terms, we have to study some related terms. First related term is interparticle force. Interparticle force, the force of attraction between two particles by which they attract each other toward themselves. Force of attraction between two particles by which they attract each other toward themselves. But now the question arises, why we are studying this term? We are studying this term to know what is the nature of interparticle force into solid, into liquid and into gas. We have to know what is the nature of interparticle force into solid, into liquid, into gas. Now see, into the solid, particles are very closely packed. Into the liquids, particles are just far from each other. Into the gas, they are too far from each other, or you can say they are very loosely packed. So you can see into the solid, particles are too closely packed. It means force of attraction is maximum between the solid. Into the liquids, they are far from each other, so force is lower than solid. Into the gases, they are too far, so the force of attraction into the gases is minimum, or you can say lowest. So according to interparticle force of attraction, we can arrange solid, liquid and gas like this. Into the solid, interparticle force of attraction is maximum, so maximum. Into the liquid, it is lower than solid but higher than gas, and into the gases it is lowest. So order of the interparticle force into solid, liquid and gas like this. Now I hope the point is clear. Now the second point is kinetic energy. Energy possessed by the moving object or particle is called kinetic energy. You know, and you read into the ninth class that moving particle always consists in energy, which is known as kinetic energy. So into the solid, liquid and gas, we have to study what is the nature of kinetic energy of the particle. Into the solid, liquid, gas, what is the nature of kinetic energy of the particle? So once again we have to draw the structure of solid, liquid and gas particles. So let's start. Into the solid, particles are too closely packed, so there is no space to move, and when there is not much space to move, the energy will be the lowest. Into the liquids, particles are far apart and they can move. Into the gas, they are very loosely packed and they can move very fastly, so energy will be the highest. So into the solid, kinetic energy is lowest. Into the liquid, it is more than solid and lower than gas. Into the gas, it is highest. So order of the kinetic energy between solid and liquid and gas we can show like this. Now the point of the kinetic energy is also clear. Now the third term is density. Mass per unit volume is called density. It means density is directly proportional to the mass. We have to go through this. Now what is the nature of density into the solid, into the liquid and into the gas? We have to study about this. Into the solid, same again, particles are too closely packed. Into the fixed volume, there are more particles. When there are more particles, so mass will be greater. Into the liquids, particles are loosely packed, so mass will be low into the fixed volume. Into the gas, they are very far apart from each other. It means mass will be the lowest. So according to mass and density relation, we can consider that the density of the solid will be maximum, density of the liquid will be lower than solid but higher than gas, and into the gas the density will be the lowest. So this is the relation, or this is the order of density into the solid, liquid and gas. That's it.